Right, so the question I'm having a look at is 2020 higher level question C4 from section C of the paper. It's the dynamic mechanism section, and like I said, it's question 4. Now I'm just going to be looking at part A for this question, so the cam. Now in this question what we're going to have to do is we do have to complete a displacement diagram for it, as well as the actual cam profile itself. Now a couple of things to point out. The cam is going to rotate in a clockwise direction, as indicated by the arrow here as well, and they've put the degrees on it for us as well, so we can't really mess that up. But if that 90, that 270 and the 180 weren't in there, then we'd have to know to label it anti-clockwise if it's telling us to rotate clockwise. It also has a diameter 20mm camshaft, so that's the center of the cam there. And then we've 0 to 90 rise as shown in the diagram, so that's basically given by that curve. We have a dwell as shown in the diagram, so that's the radius 100, and then 180 to 360 we have a return to initial position with simple harmonic motion. Now also what's important is that they ask us to use a distance of 12mm to represent each 30-degree interval, so that's to do with our displacement diagram. The gaps between the 30-degree intervals is going to be 12, so it changes year by year. Sometimes it's 10, sometimes it's 15, but in this case it's 12 we're asked to do. So we're given dimensions here for our cam, so we're going to start by drawing that. So I'm going to find a center, and then I'm going to work from there. So I'm going to start with the easiest section, which is probably the radius 100, so it's in that quarter there. And once I do that, then I'll be able to complete this quarter here, and this half then is done with simple harmonic motion, so we'll have to do that later on. So I'll start with that. All the dimensions are given in the question, so there's kind of no trickery to it really. I'm just going to start with horizontal line. And I'm also going to put in a vertical line, so this vertical line is going to be the vertical center of my cam, so it's an inline knife edge follower, so that's going to be the center of everything. Now its diameter 20 is the center of the cam, so I can draw that in now as well. So diameter 20 or radius 10, so it's handy if you have one of these to just pop that in. And like I said, I'm going to start with the radius 100 for this quarter of the cam, so I'm going to put 100 on my compass. And I'm going to start by swinging that. So that's the bottom left quarter of my cam. Now we're given the center position for the circle that does the top left quarter of the cam here. So it's across 40 from the vertical center, and it's down 12 from the horizontal center. So I can do that. I'm going to measure across 40. And I'm going to measure down 12. That gives me that center point there. And we can put the point of our compass there, and it just says R, so it's not a given radius, but we know that the center of it is here, and it goes out to this point here. So I'm just going to measure out to there, and I'm going to swing it around until it hits here. So that's as much of the cam that we can draw at the moment. We're not given dimensions for this side, but we're told that it's a simple harmonic motion, so we're going to have to do a bit more work before we can draw that in. Now, as with all cams, we're going to have to divide this up into 12 parts. So using our 60-30 set square, we're basically going to divide it like a clock. I'm going to do the right side as well, because I will need it later on. Now, this one here in the middle, that's our 0 degrees. So I'm going to label that as 0, and it is rotating clockwise. So we're going to label it anti-clockwise. Now, as I said, that's already given. Like we were told that this one is 90 and this one was 180 down here. But if that wouldn't be the case, if it's turning clockwise, then we label it anti-clockwise. So this one was 30, 60, 120, 150, and so on and so forth. Now we need to set up where our displacement diagram goes. Now the bottom of the displacement diagram is always going to be at this position here. So along the vertical axis here, and this is the lowest point of the displacement diagram. So that's the nearest approach of the follower to the cam center. So basically when the knife edge is in here, this is the lowest point that the follower goes to. So that's always going to be the case. So I'm going to draw a line across from there, and that is the bottom of our displacement diagram. So I'm going to mark off my 12 sections over here for my displacement diagram. Now they've asked us to use 12 millimeter spacings. So I'm going to put one at 0, then I'm going to have to measure out 12, 24, 36, 48, etc., etc. If maths isn't your strong suit, you could just put 12 in your compass and just mark 12 times. That would be absolutely fine. I'm going to label these while I'm here. So that's those. Now, what we're going to have to do is the points of our cam where they hit our 30-degree sections here. So all these points, we're going to have to rotate those around until they're on our vertical axis. So like this is, we're basically working backwards from how we would normally go from the displacement to draw the cam. We now have the cam and we're trying to position them on the displacement. So this bottom one is going to be along here. So the first point is going to be here. We know that, and it's going to finish at 0 as well. So it's going to go up and it's going to do its displacement and it's going to start and finish at 0. But what I'm going to have to do is put the point of my compass on the center of the cam and rotate this point onto the vertical axis. So there, and I'm also going to do the same to 60. So rotate that around, and I'll do 90. Okay, now we've got a dwell here, so 120, 150 and 180 are all going to be on that. So they're all represented by that single one here. Now the other thing it does is this is the furthest point away from the displacement. It just happens to be at this location. It could be somewhere else depending on the shape of it, but that is the furthest, and we can see that anyway based on what they've given us in the question. This is the furthest that the cam is going to, or the follower is going to move away from the center. So that point at the top here is actually the height of our displacement diagram as well. So we can transfer that across, and that then allows me to complete the area for my displacement. That's all of those. Now we simply just work with what we've got. So this one was on the 30-degree line, so this one we can bring across until it hits the 30-degree line here. So that's a point in our displacement diagram. Next point to do is just 60, so this is the 60-degree line here. We rotated that up into the vertical axis, so transfer that across until it hits the 60-degree one here. We can do 90, so that's actually represented by this at the top. And we know that continues right over to 180, so 120, 150, 180, they're all going to be, we were told in the question that it's a dwell. And a dwell is just a horizontal line like so. I'm going to draw a curve up through these points here. So based on the shape of that curve, it's probably something like a UAR. We're just not told that. That's that section of the displacement. Now, the remaining section, so from 180 right back around to 360 or to 0, is simple harmonic motion. Now that starts here at 180 and it's going to finish at 0. So we're going to have a fall simple harmonic motion from 180 down to 0. Now luckily for us that this section is actually already split into 6 parts. So the rectangle that I'm drawing here is for the simple harmonic motion. It's going into this rectangle. And as we can see, it's already divided into 6, which makes life a lot easier for us. It means we don't have to do a construction. Now, simple harmonic motion, we're going to have to get the center of the height, or so half of the height. So I'm just going to go to the end here and just bisect it. Gives me the center, and then I can draw my semicircle. So I'm going to pop it there. You then divide that semicircle into 6 parts. So start point is here. The next point, so it's going to be along this next line here on the 210 line. What I'm going to do is I'm going to bring the next point down from the across from the circle, should I say. So this point comes across and we end up with a point here. Then I'm going to take the next one and that's going to go to the next line. Start here, then the middle line here. We're just working our way down. And again, it's just a freehand curve. So there's our curve. Now, that's our simple harmonic motion done in the displacement. Now we're going to do what we normally do by bringing it from here into our cam, so that allows us to finish this half of the cam profile. So basically, where it crosses the 210, 240, 270, 300 and 330 lines, we're going to bring them across onto this vertical center here. To make it a bit clearer, I'm going to use orange marks along here for those. And I'm going to rotate these right around until they hit the line that they represent. So this one here at the bottom is the representative 330 one. So I'm going to swing it right around until it hits the 330 line there. And I'm going to go up. This will be the 300. We're up to 270. And finally the 210. So those are the points for the simple harmonic motion. These ones are free-handed. Okay, so there should be good flow to the cam. So particularly between these points there should be good curve, it should flow nicely. And it finishes at something like that. And that's the full question done. Well, part A that is.